Hello children, welcome to my channel. The chapter is Quadrilaterals for standard 9. This is part 6. We are going to prove another property of a rhombus. You know the rhombus, the diagonals are perpendicular to each other. So we are going to prove that property. So given ABCD is a rhombus, that means you are going to take all the sides are equal. That means AB equal to BC equal to CD equal to AD. That is the property, the basic property of a rhombus. And now you have to prove BD is perpendicular to AC. That means angle AOD, AOB are all 90 degrees. So whenever you have to prove it is 90 degrees, you should always take the adjacent triangles. Now I am going to take these two triangles. Consider the triangle AOD and AOB. So in left hand side, all the sides or angles, all the datas of AOD you will write, and on right hand side all AOB you will write. So AOD side AD equal to AB, and then AD equal to AB. The reason is ABCD is a rhombus. And then AO equal to AO is common side, and then you have OD equal to OB. The reason is diagonals bisect in a rhombus. Say rhombus is a parallelogram, diagonals bisect each other. Therefore, triangle A, we started with AD, no? So we will start with D. AO is congruent to triangle BAO. Write it in the same sequence. Now we can say AOD, angle AOD is equal to angle AOB, CPCT. Let's check where this AOD is. So AOD is this one, we will put this as 1, and AOB is this. So we got angle 1 equal to angle 2. But we know angle 1 plus angle 2 is equal to 180 linear pair. Therefore, angle 1 equal to angle 2 equal to 90 degrees. That is, you got angle AOB equal to angle AOD equal to 90 degrees. So all the angles will be 90. Therefore, AC is perpendicular to BD. Coming to the next question, if the diagonals of a parallelogram are perpendicular, then it is a rhombus. See, it is the converse of the previous property. The previous question, given it was a rhombus, you have to prove the diagonals are perpendicular. Now here the diagonals of a parallelogram are perpendicular is given. You have to prove it is a rhombus. So again, in a rhombus you have to prove the adjacent sides are equal, because it's a parallelogram. If the adjacent sides are equal, it becomes a rhombus. So adjacent sides you have to prove. Suppose we are going to prove AD equal to AB, then we will consider the adjacent triangles only. So these are simple tips that how you can remember how to identify the triangles which you have to prove it is congruent. So we will consider these two triangles, triangle triangle AOB and triangle AOD. So AOB, we can say BO, diagonals are perpendicular. So these two are equal. So we will start. We know O, this is O. So OD equal to OB side. The reason is the diagonals bisect each other. So these two will be equal in a parallelogram. Diagonals bisect each other in a parallelogram. So OD equal to OB. Then you have, we will put this as 1 and 2. Angle 1 equal to angle 2. It is given. And then AO is common. AO equal to AO, common side. Therefore, triangle DOA is congruent to triangle BOA. SAS. So from this we can say DA and BA. DA is equal to BA. If you see, it is DA, this is DA and this is BA. When you write the proof of the congruence, write it in an order like this, so that it looks neat. In a column, write the data here, which criteria you are taking and the reason. So therefore, in a parallelogram, if adjacent sides are equal, it is a rhombus. The next question is, if the diagonals of a parallelogram are equal and intersect at right angles, then the parallelogram is a square. So this is a specific property of a square. Normally we know about the square, the sides are, all the sides are equal and the angles are 90. Now regarding the diagonals, this is a property. This is how you differentiate between a rhombus and a square. Here the diagonals are, in a square the diagonals are equal and then it intersects at right angles. That intersection at right angles is common for rhombus and square. So if both are there, the diagonals are equal also and intersect at right angles, then it is a square. So that's what that property that we are going to solve. Now ABCD is a parallelogram given, the diagonals are equal, so AC equal to BD, they intersect at right angles, so angle AC perpendicular to BD or AOD, AOB, BOC and COD are all 90 degrees. So ABCD is a square. Now you have to prove adjacent sides are, I have told you, to prove it is a square, you have to prove the adjacent sides are equal and also the angles are 90 degrees, the vertices are 90 degrees. Because just if you prove only the sides are equal, then it is a rhombus. So you have to prove both. Okay, now we will start. So first we will prove the sides are equal. So, we have already proved this in earlier videos. So, please do it. I will just write the triangles. Triangle AOD is congruent to triangle BOA. How you will do? It is BO is equal to OD, then 90 degrees, angle 1 equal to angle 2 will be 90 degrees, and then AO equal to AO, then it will be SAS. You can say the two triangles are AOD and DOA. DOA and BOA. Therefore, you can say AD equal to BA, AD equal to AB, CPCT. So, adjacent sides, if adjacent sides of a parallelogram are equal, then it is a rhombus. Now, we will prove the angles are, the vertices are 90 degrees. So, when the vertices, whenever you have to prove the vertices are 90 degrees, you have to take these triangles, that is DA, B and ABC. So, consider the triangle DAB and ABC. So, we have AD equal to BC side, because we have already proved it is a rhombus. And then you have AB, AB equal to AB common, and then you have BD equal to AC, it is given, the diagonals are equal. So, BD equal to AC. Therefore, triangle, we started with AD, then we went to AB. So, we will write DAB is congruent to CBA. SSS criteria. From that, you can write angle DAB is equal to angle CBA CPCT. DAB is this one, and CBA is this. Now, we know AD and BC are parallel. AD is parallel to BC. Therefore, angle DAB plus angle CBA is equal to 180 degrees. The reason is co-interior angles are supplementary. Therefore, angle DAB equal to angle CBA equal to 90 degrees. So, in a rhombus, one angle is 90, all the angles will be 90, therefore, it is a square. So, here also you have two proofs to be done, one for the side and one for the vertices angle. Hope it is clear. So this will come for 4 or 5 marks. So you have to write everything neatly so that you will not be lost. Now we have to prove the diagonals are equal. So to prove the diagonals are equal, you have to consider the triangles in such a way the diagonals are a part of that triangle. So here either I can take with AB as the base, ABD and ABC, the two triangles, and prove it is congruent, or with CD as the common base. So ADC or DBC, either way you can do. Now I am going to do with ABD and ABC. So we have, so if you are getting confused with that figure, you can draw it like this. This is ABD, ABC. You can mark also AD is equal to BC, we know, and we have proved angle A equal to angle B, and AB will be common. So AS is what we are going to use. So AD is equal to BC is given. It is an isosceles trapezium, so the non-parallel sides are equal. Then angle A equal to angle B, angle proved, and then AB equal to AB is common side. Therefore, the triangle DAB is congruent to triangle DAB is congruent to CBA SAS. From this you can say DB is equal to or BD equal to AC. It's a very, very important question. So please practice it. So the construction part is the important thing. So we have covered almost all the properties of the various quadrilaterals. So I'll see you again with questions related to this in my next video. So till then, keep practicing. The more you practice, you will become comfortable in identifying the triangle, the criteria which you have to use to prove the congruence, and even the properties of the quadrilaterals, because you will be using on all the proofs, you will be using these properties in finding the angles. Okay. So see you again soon. So till then, bye from me and good luck to all of you.